Up until this point, we've been doing everything in CPP files, but before we go any further, I think I'd like to clean things up and start using header files. So the first thing I'm going to do is rename typedefs.cpp to typedefs.h, just to turn this into a header file. And everything that includes typedefs.cpp will now need to include typedefs.h. Alright, so we've fixed it in IDT.cpp, IO.cpp, and Keyboard.cpp. The next one I'm going to do is change TextModeColorCodes.cpp into TextModeColorCodes.h, and in TextPrint.cpp, rename that from CPP to H. Right, I'm just going to move those two header files into the header files filter in my project. And now I'm going to move on to some of the other ones. So keyboard scan code set 1 could also be a header file. So we'll make that one a header file, move it into header files, and fix that in IDT.cpp, just change that from CPP to H. Now converting the other CPP files into source and header files is going to take a little bit more work, but in the end it's going to make a better project layout. So we'll start with IDT.cpp. Under header files, add a new item, IDT.h, and instead of including IDT.cpp, we'll include IDT.h. Now we need to declare everything in IDT.h that we need to access from other source files. So we'll take this struct, put it into IDT.h, take our includes, put it up there as well, and we need to include IDT.h. Now we need to forward declare all of these functions. So void initialize IDT, just put a semicolon after it. And we also need to move void main keyboard handler into IDT.h as well. Now we're going to need to change our compile ASM file a little bit. We need to copy this line and change this from kernel.cpp into IDT.cpp and IDT.o. And in our linker script, we need to add IDT.o to our input files. Now we can't test this to see if this works, because in the process of converting everything, pretty much everything is going to be broken. So until we've done everything, we won't be able to see if we've done it right. So let's just continue. So now we need IO.cpp. So we'll create a new header file, IO.h, and inside of IO.cpp we can include IO.h. Cut all of these definitions and the includes and put it into IO.h. And we need to do a forward declaration of all of these functions as well. Alright, now going through all of the files that use IO.cpp, we need to change that to IO.h. So in TextPrint.cpp, we need to use IO.h, and in IDT.h, we need to use IO.h as well. Now in our compiler script, just like we did with IDT.cpp, we need to do it with IO.cpp as well, output as IO.o, and in the linker, we need to add it as another input. Now the next one we need to do, Keyboard.cpp, can be made into a header as well. So header files, add new item, Keyboard.h. So we cut out the includes, put them into the header file, and include Keyboard.h. Now in kernel.cpp we need to include Keyboard.h, and in our compiler, Keyboard.cpp, Keyboard.o, and add it to our linker. Now inside of Keyboard.h we need to do our standard declaration of our handlers, our forward declaration, sorry. And we can also move these variables into the header file as well. Right, now moving on to MemoryMap.cpp, we need to create MemoryMap.h. Move our includes and structs into there, into the header file, and include MemoryMap.h. Now we could move these variables into MemoryMap.h as well if we want to access it from outside of MemoryMap.cpp, and we are going to do that just with the region counts. Right, now we need to do 4 declarations for our functions. We'll leave this variable in here because we don't want to access it from another file. And for declare this function as well. Now in kernel.cpp we rename that to MemoryMap.h, compile it, and link it. And now we can move on to the next one, TextPrint.cpp. So we'll create a file, TextPrint.h, copy all of our includes and declarations, and include the header inside of the CPP file. So now we can move cursor position into TextPrint.h because we can use that from other files, and create our 4 declaration for these functions. Now with these default parameters, we only need to declare those in the header file and not in the CPP file. Right, on to the next 4 declaration. Just as with the other one, we don't include this default parameter anymore. We only include that in the header file. Remove the default parameter. Now right, these template functions, we're going to need to do something completely different. So we'll skip over them for now and we'll come back to them. Now we'll declare float to string as well. There we go. So now we can go through and change all of the TextPrint.cpp includes to TextPrint.h. Right, now let's compile that and see what we get. So as you can see, integer to string and hex to string have not been declared. We also have other problems, multiple definition of cursor position, etc., which we can also fix. So in TextPrint.h, we need to do extern for the variable cursor position, and inside of TextPrint.cpp, we need to keep the declaration inside of the CPP. Similarly, inside MemoryMap.h, we need to do extern usable memory region count and keep that declared inside of MemoryMap.cpp as well. And now in Keyboard.cpp, we can declare these as extern. Just copy it before we put the extern keyword. So extern right shift pressed, and extern uint8 last scan code. And in Keyboard.cpp, we can put these variables back in there. Also inside of Keyboard.h, we need to get rid of these initializations because they're external variables. Now the last thing we need to do is to go back to TextPrint.h and TextPrint.cpp and resolve the problem of these template functions. Now you can't neatly declare a template function inside of a header function. You can copy this entire function to the header file, but that will considerably bloat your file, and that's not always something that you want. So what we can do is this: const char hex to string uint8 value, return hex to string value. And we do that for every single type that we want to be supported by this function. So we have uint8, uint16, uint32, and uint64. Right, so that's all of the unsigned integers taken care of. Now we need to do the signed integers, which is char, short, int, and long. Or rather long, just to be sure. Now, we can copy all of these, go back to TextPrint.cpp, copy them down, and just make them as for declarations. Right, now we have to do integer to string, so we can just copy all of these and swap out the values for what we need. So we'll copy integer to string and replace all of the hex to string with that. Now copy all of this, go back to TextPrint.h, paste those in, and turn them all into for declarations. Alright, now we can test that and see if we have any more errors. Now before we can go ahead and test it, there is one more thing that I forgot to add. In our template declarations for integer to string, we need to add the arrow bracket and the type that we are returning. So for uint8, we are returning the template function for integer to string of uint8, and so on and so forth. So we'll just copy those in, 16, 32, 64, char, etc. long, and we'll do the same for hex to string. Right, now in compile ASM, we need to add TextPrint.cpp to our compiler, and then add it to our linker as well, TextPrint.h. Now we can see if that works. So we have multiple definition of main keyboard handler. This is happening because we're declaring main keyboard handler in IDT.h, but we can just do extern void and then declare it inside IDT.cpp. Now, as you can see, we're getting a warning Pragma Once in main file, but that's only because we are compiling these separately and it's giving us this warning. It's not actually a critical warning, it won't actually do anything bad, but we'll just have to put up with that. There might be an argument we can add to the command to stop that warning from coming up, but I'm not sure if that exists. Now we should be able to compile and run and get the exact same result as we did in the last video. As you can see, here we go. Now I did have one problem. I just needed to make sure that in diskread.asm I'm reading enough sectors because our file size has now grown to 19 kilobytes. Well, mine has. Yours might be a little bit different, but just be sure that you're reading enough sectors to read the entire kernel into memory. That'll be it for this video. As always, thanks for watching, and I'll see you next time.